Hello my dear students, good morning. Hope you are fine. Again we will continue class with the chemical bonding, MO theory, molecular orbital theory. So here I won't give much. In previous, hybridized orbitals are forming by central atom. Hybridization belongs to central atom I said. So atomic orbitals are combining and forming the particular hybridized orbitals. Number of atomic orbitals, how many combining? Those many hybridized orbitals you will have. One s and two p orbitals if combined, then 3 sp2 hybridized orbitals will come. One s and 3p orbitals if combined, then sp3 hybridized orbitals 4 will form. But in this MO theory, according to MO theory, what we learn, in formation of particular covalent bond, molecular orbitals will form by atomic orbitals. So what I am saying here, according to MO theory, atomic orbitals will combine and forms molecular orbitals. So those molecular orbitals will form sigma bonds and pi bonds according to this MO theory. Got it, sir, everyone? Sigma bond means everybody knows. So two orbitals will come through, approach through internuclear axis and form sigma bond. End on end overlapping. Pi bond means like this, lateral overlapping like this. So that kind of bonding was explained in this molecular orbital theory actually. So this molecular orbital theory, according to that, atomic orbitals, how many combining, those many molecular orbitals will form. So how many atomic orbitals means if two s orbitals will combine, degenerating orbitals, those are important. Two s orbitals are combining, then two molecular orbitals will form. And that overlapping depends on that approaching. Two atomic orbitals are approaching in same plane, means wave will be like this actually. Electron in a particular atom create a wave like this, and this is plus and this is minus. This is plus and this is actually minus like this. So when you see here, this is the positive lobe actually, so which we call positive sign, and this we call as a negative sign, amplitude. So here this plus side is giving positive probability of finding electron. This minus side will give you negative probability of finding electron. So if s orbital is overlapping, combining, not overlapping, s orbital is overlapping with plus and plus like this, then there are two types actually. This is a symmetrical overlapping. What this is called? Symmetrical overlapping. S orbital plus and s orbital plus, plus and plus. So every orbital has two. One is positive probability, one is negative probability. So two positive probabilities of two s orbitals of two atoms, if overlap, then you will get what? Like this. What this is called? Sigma 1s like this. Now s orbital plus another s orbital of another atom, if minus means positive probability of one atom, negative probability of another atom, for what? Finding electron. If they are overlapping, not overlapping, sorry, please. It is when combining, then that is called unsymmetrical combination actually. Overlapping you can say, but they are forming molecular orbitals, that's why. Combining, and here also combining you can write, and they give the like this actually. So this is actually now plus and minus and plus like this, and this is called sigma star 1s. Why I am telling this? This is called bonding molecular orbital, and this is anti-bonding molecular orbital like this. Always remember, sigma 1s is having less energy than sigma star 1s. What is this? Order of energy. Why? This sigma 1s is more stable. Stability is inversely proportional to energy. So this is more stable, so less energy. More stable, so less energy. So sigma 1s, which is called bonding molecular orbitals, are always having less energy than anti-bonding molecular orbitals like this. Okay, so very important how bonding molecular orbitals and anti-bonding molecular orbitals are forming. So when two orbitals are overlapping, two atomic orbitals. This is what atomic orbital of one atom. This is atomic orbital of another atom. Suppose two hydrogens. This is one hydrogen. This is one hydrogen. So this is the oneness of this hydrogen. This is oneness of this hydrogen. But these molecular orbitals both are belongs to H2. Understand? Because this hydrogen and this hydrogen both are combining and forming H2. Then this H2 has two molecular orbitals. One is sigma 1s and one is sigma star 1s. Hope you understood. So this is about how bonding and anti-bonding will form. Okay, afterwards actually atomic orbitals means like this, 1s, 2s like this. You know this, 1s has less energy than 2s. So this 1s has two molecular orbitals. One is sigma 1s and one is sigma star 1s. Like that, these 2s have two. One is sigma 2s and sigma star 2s. So same story. Sigma 2s is bonding, sigma star 2s is anti-bonding. Anti-bonding has more energy. So very important. So here you can write. So after sigma star 1s and you will get sigma 2s. Sigma star 2s like this. This is order of energy for s orbitals. So why 2s you written afterwards means 1s orbital actually have less energy than 2s according to that n plus L value in Euler diagram I shown in previous class. Okay, so like that. So sigma 1s, sigma star 1s, sigma 2s and sigma star 2s. Now how those p orbitals will form molecular orbitals we have to see next. Understanding, sir, everyone? Please write on this. Okay? Yeah. Next, we will go for p orbitals, how they are forming anti-bonding orbitals as well as bonding molecular orbitals. So, as I shown in previous, if this positive probability of one atom and the positive probability of another atom gives bonding molecular orbitals. Positive probability of one atom, this is wave cell, this crusted trough we call that one, and negative probability of other atom if combined then gives anti-bonding molecular orbital. Like this you have to write. Okay, same way here I will write how p orbitals will form. P orbital means p subshell have three degenerating orbitals. One is px, py, pz. Another atom has p orbital, same manner, px, py and pz. So total, how many degenerating orbitals? Here you have 3 orbitals and here also you have 3 orbitals. So 3 and 3, 6. So 6 atomic orbitals are combining. 1, 2, 3, 4, 5, 6. So 6 atomic orbitals are combining and gives definitely 6 molecular orbitals. Same story, one is symmetrical overlapping and unsymmetrical overlapping. Remember, here symmetrical overlapping and unsymmetrical overlapping gives, there are 6 molecular orbitals. Why, sir? This is the 2p subshell, suppose, of a particular X atom. This is 2p subshell of particular another X atom. Then X2 has molecular orbitals. How many molecular orbitals you will have means 6 molecular orbitals you are having, because this 2p has 3 orbitals, this 2p has 3 orbitals, means total you will have 6 molecular orbitals. Among 6, half are bonding molecular orbitals and half are anti-bonding orbitals. Understanding, everyone? So as I said, if x number of molecular orbitals you are getting, among x number of molecular orbitals, x by 2 are bonding molecular orbitals, x by 2 are another anti-bonding molecular orbitals, equal. Okay, so here in that way there are 3 bonding molecular orbitals and there are 3 antibonding molecular orbitals you will have. Those structures we discussed in first year itself. So those three bonding molecular orbitals are what? Means, see, when three orbitals are combining, when three bonds are forming, I told you many times, if particular compound has a double bond, then one is sigma bond and one is pi bond. If three bonds are forming, then one is sigma and remaining two are pi. So three combining, definitely triple bond is possible. So like that you have to remember. So three bonding orbitals among those, one is sigma and remaining are pi. Sir, sigma 2px can we write? Yes. Can we write z? Yes. No problem. Px, py, pz among any one of that will form sigma and remaining two will form pi. And pi 2py and pi 2pz which are having equal energy. So sigma 2px and pi 2py and pi 2pz have, see, this has different and less energy and these two have more energy actually. Why? Pi bond is weak than sigma. Sigma bond means through internuclear axis, strong bond. Certainly sigma bond has less energy and pi bonds have more energy. But these two pi orbitals have same energy. And remaining anti-bonding you have to write like this. Sigma 2px star and pi 2py star and pi 2pz star, like this. So we indicates anti-bonding molecular orbitals with star. Understanding everyone? So 6 atomic orbitals. Suppose this is 2p means this is 2px, this is 2py, this is 2pz. 2px, 2py, 2pz of another x atom. This is x atom, x atom. So 3 and 3, total 6 atomic orbitals are combining. 6 atomic orbitals are combining and giving 3 bonding molecular orbitals and 3 anti-bonding molecular orbitals. Among 3, always remember, one is sigma, remaining 2 are pi. Why sir only one sigma? Because only 2 atomic orbitals can combine or can come closer through internuclear axis. I repeat, only 2 orbitals can overlap through internuclear axis. So only 2 orbitals are overlapping means only one bond is possible, one sigma bond is possible. So remaining have to form pi bonds. Suppose this is y and this is y, 2py. This is z and this is z, 2pz. Like that you have to take. Understanding? So now what is the order of what is the order of molecular orbitals? If you see, I will write up to 14 electrons and greater than 14 electrons as two different energy orders I will give you right now. So how these are forming? I given. So bonding molecular orbitals are how forming and anti-bonding orbitals how forming. Bonding molecular orbitals are forming through combination of atomic orbitals in a symmetrical manner is giving bonding molecular orbitals. Atomic orbitals, if combining in unsymmetrical manner, means a positive probability combining with negative probability, you will get antibonding. I will show you that bonding molecular orbital of P. P means dumbbell, everybody knows. Okay, so this is minus and this is plus, and this atomic orbital of one atom. So this is combining with another atomic orbital. So this is atomic orbital of x, and suppose this is 2px and this is 2px of another x, then you will get sigma 2px. Is it having star? No, because plus plus combined. Sir, plus plus only na sir? Minus and minus if combined? Yes, that also you can take. So now what you are having like this, like a chocolate. So this is plus and here this is minus and this is minus. So total this plus charge and this plus means positive probability finding electron. Positive probability of finding electron. Both will be in a one area like this, becoming identical. Okay, so this is sigma 2px and pi 2py, sigma star 2px are forming your plus and your minus. Those you have already structures. Okay, So I'll show you one is bonding molecular orbital of pi. This is formation of sigma 2px. And suppose pi 2p, why how forming? If you know about this, pi 2p z also you can say, not a problem. So now plus, plus, minus, minus. This will give what? Plus here, minus here. This is pi 2p1. So this is atomic orbital, like it's 2py, and atomic orbital 2py. Both are combining. Okay, and you are getting pi 2py. Antibonding, plus here, minus here. Minus here, plus here. Antibonding you will get. Understand? So antibonding how you will get? Let's see. Plus minus antibonding means suppose pi star 2py. How you will get? So here minus plus. Now how you will get? What you will get? Here suppose this is atomic orbital and this is atomic orbital. This is 2py and this is 2py. Both are combining like this. But now like this. Plus minus. Minus plus. So they are not symmetrical. Because plus cannot combine with minus. Why sir? Plus and minus means they combine easily also. No, not like that. Here, what is the reason? So plus means like this. Minus means like this. They cannot overlap. While combination, they cannot come closer. No. This is above the plane and this is below the plane. So they cannot come closer. So this is what we call a pi star 2py. So that you can write pi star 2pz also. So this is about how shapes you will have for molecular orbitals. Have a look and write down all these things. Okay, thank you. Next, we have to discuss, as I said, order of molecular orbitals, energies. Because why we have to learn? Because we have to fill electrons by considering their energies of molecular orbitals only. Okay, so now we have to discuss order of energy of molecular orbitals. We have to learn. But first thing is up to 14 electrons. That is up to N2. Up to what? Nitrogen we have one order. The number. Nitrogen means don't think N2. Okay. So what is the order? I will write increasing order of energy. Okay. Sigma 1s. As I said, next sigma star 1s. Next sigma 2s. Next sigma star 2s. Next pi 2py is equals to pi 2pz is next sigma 2px. Next pi star 2py is equals to pi star 2pz. As I said, anti-bonding orbitals are always having more energy. Okay, so that's why even these are pi. These are bonding pi. These are anti-bonding pi. And sigma 2px, but last is sigma star 2p. Shit, already 2 written. Sigma star 2px. So can I write Z and here Z? No problem, not a problem. Okay, so this is order of energy, what we have. Important. So this is order of energy of molecular orbitals up to 14 electrons. Suppose if they given what is suppose like Cn, okay, Cn like this given, what is its electronic configuration? So total electrons you have to take, not valence electrons. Remember, in molecular orbital theory, total electrons. While writing VSEPR theory and while finding hybridization, valency electrons only. Remember. So here, what are the total number of electrons? Carbon 6 and nitrogen 7 you have to take. Their atomic numbers. Carbon 7 and nitrogen. Sorry. Carbon 6 and nitrogen 7. 6 plus 7 total 13. So less than 14 electrons, up to 14 you can consider this. So 13 electrons how to fill? First always remember 10 electrons you fill. And one more important thing is each molecular orbital can have maximum 2 electrons. Can have maximum how many electrons? 2 electrons. Similar way, degenerating orbital means one dabba. In that one dabba, how many electrons you can fill? 2 electrons. Like the molecular orbitals, one dabba. In one dabba, how many electrons you can fill? 2 electrons. So like that, if you see, first when you have 13 electrons, first you fill 10 electrons. 1, 2, 3, 4, 5, 6. 6 to 12. First you fill like 8 electrons, 12 electrons you fill, not a problem. Or 8 electrons you fill. So without writing you have to say, first you have to write, but without writing that, you have to fill 13 electrons. Because each molecular orbital will have 2 electrons, I said. So 2, 2, 2. So first, otherwise you can count like this. 1, 2, 3, 4, 5, 6. 6 to 12. Okay. One more electron. So that one electron will be here. From that, what you can say? Here, okay, Cn is a paramagnetic. Cn is paramagnetic because unpaired electron. And having how many unpaired electron? Unpaired electron is equal to 1. Okay, so magnetic momentum is 1.73. I told you many times. If unpaired electron is 1, answer is 1 point something, but nearer to 2. If number of unpaired electrons are 2, then answer is 2 point something, but nearer to 3. Okay, so like that I said. Magnetic momentum you can say, paramagnetic you can say. And configuration, which of the following is correct configuration for Cn means now you can write like 2, 2, 2, 2, 2, 2 and 1. Here 1. So this is the configuration of Cn now. 1, 2, 3, 4, 5, 6, 6 to 12, 12 plus 1, 13, like that you can fill. Okay, 13 electron how to fill, 14 electron how to fill, 1, 2, 3, 7 orbitals we have to count. 1, 2, 3, 4, 5, 6, 7, 7 to 14. This is simple way to write electronic configuration. But this order, but this very simple actually. First 1s, both bonding and antibonding. Next 2s, both bonding and antibonding. But up to 14 means nitrogen. Till nitrogen, multiple bonds means pi bonds are more stable. So pi bonds have less energy than sigma 2px. Here only. Otherwise you will ask me tomorrow, sir, you said sigma is more stronger overlapping, that must have less energy. So 2px must be here. No. This is the order of energy. Okay, because pi bond system is more stable here. So energy is less. You have to remember. Okay, unpaired electron I said, as I said, if you know number of total valence total number of electrons, not valence electron. Total number of electrons means what? Sum of the atomic numbers. Carbon 6, nitrogen 7, like that. Now, what is the order of energy of molecular orbitals but greater than 14 electrons? Even 14 you have to follow this. Greater than 14 electrons. What you have to? Same as it is copy paste, but these two you have to reverse. Then what you will write? Sigma 1s. Okay. Sorry. See what I am doing all these things like a small kid. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and these two just interchange. What I written in box, that just flip. Okay, then what you will get? Sigma 2px and pi 2py and pi 2pz. Then no change. Pi star 2py, pi star 2pz, and highest is sigma star 2px. Highest energetic, least stable. Stability is different. Energy increasing, stability decreasing. So because energy and stability both are what? Inversely proportional. This order you have to fill, and this is the change what we made. Suppose like some NO given. So NO means nitrogen 7, oxygen 8. 7 plus 8. 7 plus 8 how much? 15. Yeah, 15. How to fill 15 electrons? I'll count orbitals first. 1, 2, 3, 4, 5, 6, 7. 7 to 14, 1 electron. So 1 unpaired electron you will have there. So this is also paramagnetic. Suppose O2, 16 electrons. Each oxygen atomic number? Yeah, oxygen 8. 8 plus 8, 16. Why I struck there? Don't know. Oxygen atomic number is 8. 8 plus 8, 16. 16 how to fill? 8 orbitals. But 1, 2, 3, 4. Few people very talented. They will say 16, even number. Okay, 8 pairs. It's not having unpaired electron. They will say like that. But you have to check the orbitals. 1, 2, 3, 4, 5, 6, 7. 7 2s are 14. Remaining 2 electrons you will have. Those 2 electrons, these are equal energetic, no? So 1 electron you have to fill. That's why O2 is paramagnetic in nature. Now maybe habituated many people, but few people will think like that. N2, 14 electrons. So 14 means I told you already. So 1, 2, 3, 4, 5, 6, 7. 14 over. So pair. N2 is diamagnetic. Magnetic momentum you can say. Okay. So after this last and final, which we call as a bond order, very very important. Okay. So greater than 14 electrons, how to write also I told you. So less than 14 electrons and up to 14 electrons, what we have to follow? What we have to follow, I said. Now we have to discuss actually MO diagram, you know, I think so. We will write like this. So revision, no, I can do like this only. This is S. S means 1 dabba, everybody knows. So S means 1 dabba. So you will have bottom, you will have sigma 1s because bonding molecular orbital have less energy, and pi means like this you will have. It's not writing properly. Pi means P means you will have like this. P has 3 atomic orbitals. I said P means 3 atomic orbitals. So total there will be a 6 molecular orbitals. I said many times. So up to 14 electrons if there. Then in this diagram, pi 2py and pi 2pz has less energy, and sigma 2px will be top, somewhat means above to these two. I told you order, no? So these two have less energy. I told you in that order. So that, and here you will get pi star 2py and pi star 2pz, and here sigma star 2px, like this you will have. And one more important thing is that, please remember everyone, up to 14 electrons, this one, same diagram. Greater than 14 electrons means what you have to do? This will come here, these two will go up, like that. That's it. Okay, sir? So very important, you have to follow this. Okay? Next, how to have bond order. I told you one trick already. Excuse me. Actually, bond order means total number of bonds formed between two atoms, present between two atoms in a molecule. Okay, in a molecule, how many total number of bonds are possible between two atoms? That is called bond order. Actually, bond order, you have formula. What is that? Number of bonding electrons minus number of anti-bonding electrons, okay, by 2. Bonding electrons means what? Without star. Anti-bonding electrons means what? With star. Those. Okay. So in that way you will have bond order. And bond order to have, I told you one thing, one shortcut. What is that? Bond order trick. How to remember? I told you, no? So number of electrons you write down. Number of electrons starts with 8. Because remember, in a molecule, 2 electrons are there. Total 2 electrons and 6 electrons. Then bond order is 1. If total electrons 4, then bond order will be 0. Okay, 4 electrons are what? He2. 2 electrons are what? H2. 6 electrons what? Li2. Lithium atomic number 3 no? Li2 means 6 electrons. Hydrogen H2. Hydrogen atomic number is 1. 2 hydrogens H2. So 2 electrons. So 2 electron and 6 electron species bond order is 1. Okay. Suppose like Be2 8 electrons. Because beryllium 4 atomic number. So 8. So from 8 you can say 8 electron bond order is 0. So I will write here. Number of electrons 8. Number of electrons 8. 9, 10, 11, 12, 13 and 14. Okay. By leaving 14, again you write down number of electrons here. Number of electrons. By leaving 14, here you write down. So what? 15. And here 16. And here 17. And here 18. And here 19 and here 20 electrons. You write down. Why 2 times I written? I will tell you. Now in middle you write down bond order. This I told you, but revision I have to explain because very important. Because bond order, if you know bond length you can say, bond energy you can say, bond angle you can say, and from that you can say acidic character as I said in previous. So when molecule number of electrons in what? Molecule. Number of electrons in molecule. This. Here number of electrons in molecule or ion. Like N2 plus, they will give sir. You have to say what is the bond order. Cn minus, Cn plus, NO plus. Like that if they ask, you can say bond order. Plus means you have to remove electron. Minus means you have to add electron. Understand? So, what is the bond order now? When the molecule having 8 electrons or 20 electrons, then bond order is 0. Now, increase by 0.5. That's it. You can have bond order. So, here 0 starts with 0. So, increase by 0. Bond order increase by 0.5. So, this one 0.5. When a molecule or ion have 9 electrons or 19 electrons, bond order is 0.5. 10 electrons or 18 electrons, then the bond order is 1. So increasing by 0.5. Now 1.5. Now 2. Now 2.5. Okay. Now here just 3. Bond order can be maximum 3. Bond order can be 0 and bond order can be fractional. But bond order can be maximum 3 because between two atoms maximum triple bond is possible. Have you seen a molecule which consists of 4 bonds like this? No, not possible. So between two atoms maximum 3 bonds only possible. So this is a very important trick for you. So you can have a bond order like this. So bond order in suppose example like as I said Cn minus, number of electrons, carbon atomic number 6, nitrogen 7, minus charge means you have to add. I told you in previous. So minus 1, so plus 1. So total 14. So 14 means what is the bond order? 3. So as the number of electrons increasing up to 14, bond order increases, but 15, 16. Again from 15 as the number of electrons increasing, bond order decreases. This you have to remember, very important. From 15, if number of electrons increasing, bond order decreases. But here up to 14 as number of electrons increases, bond order increases. Very important. But in some examples like O3, O double bond O, single bond O, O double bond O, resonating structure, O single bond O, double bond O. In this kind of resonating structures can be given, then bond order is equals to number of bonds by number of resonating structures. Resonating structures. So here in O3, how many bonds are there? Total bonds 1, 2, 3. And here how many structures are there? This one structure, this is the another structure, 3 by 2. So 1.5 is the bond order, like that. But in some examples, same story, in benzene like that, like this, if you see. What is the bond order between any two carbons? Yes, like this, if they given. What is bond order in C6H6 means any two carbons you have to compare in both structures. The total structures how many? Two. So in this structure you have a double bond. In this structure you have single bond. Like that. Here also same story. In that way also you can say. Here you have single bond, but any two oxygens you can compare. Between these two oxygens single bond. So you have one. Between the same oxygen you have two. Otherwise these two oxygens you can compare. 2 and 1 like that. Okay, total number of bonds you can say. But in benzene many multiple bonds are there and any two are identical. So total double bonds we have no need to consider. Simply we will consider 2. So 3 by 2. So here also bond order is 1.5 like that. Okay. So this is one of the important simple way to have number of what? Bonds. Number of bonds is nothing but what? Bond order. Please write down all these things. Okay. So hope you completed all these things. So how to have bond order? I said in different molecules. So bond order, one more way also you can say, simple short way. Suppose when they given like this ClO4 minus, what is the bond order in this molecule? Okay, then you have one simple trick. When any central atom means less electronegative, I told na. If, remember this trick, if central atom bonded with 4 oxygens, then total number of bonds belongs to molecule, belongs to central atom or in molecule will be is equals to its group number of central atom. Then in ClO4 minus, what is the bond order? If they ask, you have to know the formula. What I said, I told you this, number of bonds by number of resonating structures. I written number of bonds. See here, chlorine bonded with 4 oxygens. For oxygen mostly they'll ask. So this is one of the trick. So chlorine group number is 7. So 7 bonds are present. Like that I will say. And here number of resonating structures, how to find? Simple trick I will give you. Here what is the number you have? Those many resonating structures you will have. So simply number of resonating structures are nothing but number of terminal atoms. Number of terminal atoms. So 7 by 4, this is the bond order. Understanding? Same, suppose SO4 minus 2. This negative charge, everything not important for you. This is central atom. Less electronegative. 4 oxygens are there. So the sulfur has a group number bonds. Sulfur belongs to 6. So 6 by 4 like this. You can say. So 6 by 4 means you will get 3 by 2. Bond order. Can be fractional I told. So as I said, you have. So if number of oxygens is decreasing. So if 4 oxygens are there, 7 bonds. 1 oxygen is less. Suppose like this ClO3 minus, then what is the bond order if they say? Then 5 by 3. Why 5 by 3? 1 oxygen is less from this. 4 oxygens is there. Group number you have to take in numerator. But 1 oxygen is less. 1 oxygen form 2 bonds. So 7 minus 2. So 5 by 3 you have to take like that. Okay. So in that way you can have, what is that? Bond order. This is a very important, this point you write down. Okay. Next, as I said in previous, what is that? bond order will decide many things. If bond order increases, then bond length decreases, bond energy increases. What decreases I written, remaining all will increase. Bond energy increases, bond angle increases, acidic character increases. Very, very important. Remember all these things. When bond order increases, then bond length decreases, bond energy increases, bond length decreases, bond energy increases, bond angle increases, acidic character increases. These all are very, very important, sir. Please note it down. Okay, so why bond order is important means you can have many things in different compounds. Got it, sir, everyone? So as I said many times, alkanes, alkenes, alkynes. Alkynes bond order is more. CC, triple bond in alkynes. So bond order is 3. Okay, like that. CC. So what is the bond order means 1 here. Like this in CH4 or in ethane, what is the bond order? AN. Okay, all are single bonds. Bond order is 1 between any two. Okay, so what you are getting bond order means average bonds between two atoms. Average bond is 1 everywhere. So double bond. So 2 bond order. Triple bond order 3. Like that. So when the bond order increases, then bond length. Bond order increases, then bond length decreases. Got it, sir, everyone? So next, we have this also right. Next, last and final in this. Okay. We have to discuss about what is that? Dipole moment. So bond parameters. So previously what we written, all are bond parameters only. Bond order, bond length, bond angle and bond energy. So how they will vary and how we will decide, I told you already. So in that one more bond parameters, dipole moment, we use mu. Dipole moment means mu d, otherwise it is product of charge into bond distance. Simply charge delta into bond distance. You can say d, delta into d. This is dipole moment. What is the use of this dipole moment? Dipole moment is the measure of polarity, quantity of polarity means how much two atoms charge separation is there. So how much unequally two atoms are sharing, okay, that we will decide by using this dipole moment. Dipole moment is more than the molecule is more polar, that's it. So it is the measure of polarity, dipole moment. So dipole moment we will see in debye. So dipole moment, okay, we will use 1 debye or 1.2 debye, like that we will say. Okay, so dipole moment we will say charge is 10 power minus 8, charge is 10 power minus 10, and this distance is 1 angstrom. 1 angstrom is 10 power minus 8. 10 power minus 10 is ESU, electrostatic units. This 10 power minus 8 angstrom that we converted into centimeter, ESU centimeter. Okay, this is the mu d units, 10 power minus 18 ESU centimeter, which is equals to 1 debye. Okay, so in this way you will say 1 debye is how much. SI unit, that 1 debye is how much means that you will have 3.10 power minus 30, like that you will have. That also I was given in previous. That conversion also you know already. So this is about what is debye units. Understood, sir? Next we will have in what molecules you have dipole moment. As I said many times, dipole moment will be 0 when the molecule have geometry or shape according to VSEPR theory. That means molecule having structure according to VSEPR theory, then the molecule is symmetrical. So in symmetrical molecule, dipole moment is 0. This you have to remember. So molecules with no lone pairs are symmetrical molecules. Symmetrical molecules. For those, dipole moment will be 0. Means no polarity. Dipole moment is 0 means what is the meaning? No polarity. So non-polar meaning. Okay. So example like CO2, BF3, BCl3, CH4 like this, etc. So these all, if you see, these all have structure having these are having structure according to VSEPR theory, and lone pairs will be 0. So example. So for all these, the dipole moment will be 0. Okay. So like that, I said cis trans in that where dipole moment is present. Okay. Cis has dipole moment than trans. Cis molecule. But when the bonded groups are similar, if bonded groups are same, okay, like Cl or methyl like that, H. Now dipole moment not equal to 0. Dipole moment not equal to 0 means what is the meaning? Polar. And dipole moment exists. And here C double bond C, when you have a chlorine like this, then dipole moment will cancel, polarity will cancel, because see this dipole moment is a vector quantity. So the two bonds are like this, one bond above and one bond below like this. Equally they are cancelling like this. So when dipole moment exists, I told you many times, if two bonds are like this, dipole moment exists. If two bonds are like this, dipole moment exists. If two bonds are same direction towards more electronegative atom, this arrow towards chlorine. Why? Chlorine is more electronegative than carbon. That is the reason. Understanding, sir, everyone? So here, hydrogen, chlorine is more electronegative like that. Okay. But if you have different means what, sir? If you have different groups, one is methyl and one is chlorine, then here what I said, trans, cancel polarity. So here dipole moment is 0. Dipole moment 0 means not exist. But if, here I said no this one, if cis and trans, if you compare, trans also has more dipole moment than cis if the bonded groups are different. This you write down by having screenshot. I will give you one more here only. Than cis, trans has more dipole moment, but when bonded groups are different, when different on one more thing, two groups will be there, no? One should be plus I group and one should be minus I groups. So two groups should be attached, two groups among them. One should be plus I and one should be minus I. Plus I means donor, minus I means acceptor. You know that? Inductive effect, mesomeric effect. Plus I means electron donating group. So bonded two groups actually are different. Means one is plus I and another group is minus I. Then dipole moment, if you see, trans has more dipole moment. This I told you many times. In this, here dipole moment 0 and not equal to 0, here also not equal to 0, but when one is methyl and chlorine here, but one is methyl and another is chlorine. Now this arrow is towards carbon. Why? This methyl group is a plus I group. This chlorine is a minus I group. Understanding, everyone? So this is a very, very important thing. So now this trans has more dipole moment. Understood, sir? So this is a very, very important thing. Okay? So dipole moment examples we have in a many ways. Okay? So dipole moment is a vector quantity. Dipole moment we will see, we can understand by knowing the number of lone pairs. How to know the lone pairs? I told you in previous in hybridization concept. Hybridization you can have and lone pairs you can have. Lone pairs, for that you have hybridization minus number of terminal atoms. Okay, so by using that number of lone pairs present or not, you can check. And one more thing, electronegativity of atom if increases, then dipole moment increases. Okay, so dipole moment is a vector quantity. Okay, so this kind of examples also you have in your notes, like a chlorine and chlorine, you have your dipole moment will be 0. Okay, and here if you see Cl and Cl, and here dipole moment not equal to 0, and here Cl and Cl if you see, okay, oh sorry, at ortho position, then dipole moment not equal to 0. So this is order of dipole moment. So here how you can say from the bond angle 180 degrees. So both are just opposite, one is above and one is below like this. So both are cancelling like this in opposite manner, one is above and one is downwards. So here polarity will cancel, so dipole moment is 0. So here dipole moment, here 120 degrees, here 60 degrees. So as theta angle increases, then dipole moment decreases. This is the most important thing. Why? The resulting dipole moment mu r is equals to, we know that, square root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. This one. This is a very important. But in some kind of examples like this, when the bonded groups have non-planar atoms, then actually I said para, actually this is para has dipole moment 0, but here para has dipole moment not equal to 0 for this. Do you know why? Oxygen is a non-planar atom. How you are saying oxygen has 2 bonds and lone pair, so this oxygen is sp3. How you are saying this is non-planar? It is a tetrahedral. Planar atoms means what? Trigonal planar, linear, square planar, they are planar atoms. Tetrahedral, all 4 are like this, so they are not planar atoms. So oxygen also like that, it have 2 lone pairs. So that's why even it is para, so I said here 180 degrees dipole moment 0, but here even 2 are in para position opposite, but dipole moment not equal to 0, but here 0. And this kind of example also you can have. See triple bond N and triple bond N, your dipole moment is equal to 0. Here dipole moment not equal to 0, but here dipole moment equal to 0. Why? Because here carbon is sp. Sp means what? Linear. Linear means what? This carbon is a planar atom. Here this carbon is planar atom. Okay, till this you have to understand, and still many examples I was given. In dipole moment actually I was given one more, that is how to calculate percentage of ionic character. You also please go through that. Percentage of ionic character, delta by charge of electron into 100. This I was given. Percentage of ionic character is equals to delta by charge of electron into 100. This you have to consider. Got it, sir, everyone? So this is about what? Dipole moment and percentage of ionic character based on this numericals also we did. Actually that mole concept we have to discuss. Don't worry, I will do one extra class for you, not a problem, I won't miss anything, but you have to understand everything clearly. That's why I am doing like this. I can skip all these things and I can start mole concept. Mole concept is very simple, everybody knows that 1 mole is how much, how we relate. Okay, so don't worry, one extra class if you did this, we can cover everything. That mole concept also you can cover, so not a problem. but you have to spend 1 hour extra time, and even I have to spend 1 hour extra. That's it. It's a matter of 1 hour or 2 hours. Okay, then we will have more effectively. Don't think, oh, today mole concept should happen, but still chemical bonding only explained. Don't think like it, because what we discussed are very, very important. So that's why I given all these things. Please have a look, and how to identify planar atom, everything. So many things are very much useful. Few people may think chemical bonding easy for me, I did many times, but if we have revision, we will get more and more perfect. So that's why I said. So simply, as I said, mole, why we use. So this I said 1 mole means how much. This is a quantity representation of a chemical substance. So 1 mole means everybody knows. Actually, number of moles means where there is a formula. What is that? Weight of substance by gram atomic weight or else gram molecular weight. If N is what? Mole. See, if number of moles of any particular atom, then weight of atoms by gram atomic weight. Gram atomic weight of 30 elements you should know already. You know already and you must remember. Okay, no, revise that means I won't. Okay, number of moles of any particular molecules or like that, then weight of molecules by gram molecular weight, like this. Please remember. So 1 mole, how we relate? 1 mole is equals to Avogadro number 6.023 into 10 power 23 species. Okay, what is the species means? Why I am writing species? 1 mole of atoms, Avogadro number of atoms. 1 mole of electrons, 6.023 into 10 power 23 electrons. 1 mole of ions, 6.023 into 10 power 23 ions. Like that means 1 mole is equals to gram atomic weight of 1 mole of atoms. 1 mole of molecules is equals to gram molecular weight. 1 mole will occupy, 1 mole of any gas occupies how much volume at standard temperature and pressure occupies 1 mole of gas at STP. STP means temperature, 273 Kelvin, and the pressure is 1 atmosphere or 760 mm. Occupies 22.4 liters volume or else 22,400. But this is the condition, STP or NTP. If you know this, maximum of the mole concept over, except that limiting reaction and those relations, weight relation, weight volume relation. So for that easily we can complete. Okay, and redox reactions also like that. Okay, balancing and having oxidation numbers. And one more thing is in that particularly reducing agent and oxidizing agent. Those we can easily complete. So there we can cover time. Don't worry. But you have to do one thing. You have to practice properly. Okay. Thank you very much. So practice everything what we discuss. Okay. Then definitely you can crack NEET or CET whatever. Okay. Thank you very much.